Hello everyone, welcome to another episode of Maria Studies Math. So for today, we'll be discussing about finding the greatest common factor or the GCF. So what is GCF? So GCF or the greatest common factor is the greatest number that is a factor of two or more other numbers. It is the largest number that can be used to divide two or more other numbers so that the quotient will still be a whole number. So now let's try finding the greatest common factor of different sets of numbers. So we are asked here to find the GCF of two sets of numbers. Let's do the first set first, which is 48 and 64. When we are asked to find the GCF of sets of numbers, there are actually different ways for you to be able to find the GCF. There is this listing method wherein you list all the possible factors of the given numbers, or you could also divide them by prime numbers, or another way is for you to actually do the prime factorization tree. So that is what we will be using for today. So let's try it in 48 and 64. So first, let's create a prime factorization tree for 48. So it would mean that we will have to factor 48 so that all the possible factors that we list are all prime numbers. So 48 can be factored as 6 and 8. When we say prime numbers, the factors of prime numbers are only 1 and itself. So when we say 6, we can still factor it as 3 and 2. So it's not yet 1 and itself. 3 can be factored as 1 and 3. So that would mean 3 is already a prime number. Next one, we have 6. No, sorry. Kaya ko to. So, next one, we have 2 is also a prime number because 2 can only be factored as 1 times 2. Also do the same for 8. So 8 can be factored as 4 times 2. 2 is already a prime number, but 4 can still be factored as 2 and 2, where both 2's are prime numbers. Now let's do the same for 64. Okay, so 64 can be factored as 8 times 8. Then 8 can be factored as 4 times 2. 2 is already a prime number, so encircle that to remind us that it's a prime number already. Next one, 2 and 2. And then for 8, the other 8 also do the same. So we could have 2 times 4. And then 4 can be factored as 2 times 2. Ang pangit ng tuko, but sige, kaya natin to. Now, we already have the prime factors of 48 and 64. The next step is for us to identify what are the common between the two given sets of factors. So, what we'll do is, para mas madali, let's highlight the common factors between 48 and 64. So, both of them has 2. Yung isang 2 na yan, ayan. Another 2. And then another 2. Another 2. Okay? So, from there, there's no other common factors aside from all those highlighted 2's. So, that would mean our GCF. So, sulat lang natin. Sorry, I'm so slow in writing, no? GCF of 48 and 64. So GCF of 48 and 64, that would be just multiply all those highlighted factors or common factors. So 2 times 2 times 2 times 2. So this is equal to 16. Therefore, the greatest common factor of 48 and 64 is 16. And that would be our final answer. So, lagay ko lang dito would be 16. Okay, para lang maalala natin na yun yung ating final answer. Now let's try to find the GCF of another set of numbers, which are 18, 36, and 90. It's not always the case that you are only finding the GCF of two numbers. Pwede siyang 3, 4, 5, or more. Okay, so let's try this set of numbers. Again, we will be using the same method, which is the prime factorization 3. So let's create the prime factorization 3 of 18. So 18 can be factored as 9 times 2. Again, encircle 2 because this is already a prime number. 9 can be factored as 3 times 3. So 3 are prime numbers. So we're done with 18. Subukan natin si 36. 36 can be factored as 9 times 4. And 9 can be factored as 3 times 3. So these are prime numbers. And then we have 4 can be factored as 2 times 2. So they're prime numbers again. Okay? I apologize for my handwriting, no? Hindi pa rin ako sanay until now. Next one. Chika pa, no? Chika pa tayo. Sige girl, kaya mo to. Next one, 90. We have 90 can be factored as 9 times 10. And 9 can be factored as 3 times 3. So these are prime numbers. And also for 10, we can still factor it as 5 times 2. And 5 is a prime number because the only factors for 5 are 1 in itself and 2. So now that we already have the prime factors of 18, 36, and 90, next step is highlight natin all the common factors. So since there are 3 numbers here, we should make sure that the common factor is common to all 3 of them. Okay? So first one, all of them has 3. Ayan. Next one, all of them still has another 3. And then all of them has 2. So that's all. Now, that would mean that the GCF of 18, 36, and 90 is 3 times 3 times 2, the common for all of them. And then we have to multiply them. That is equal to 18. So our GCF would be 18. And that is our final answer. So I hope you learned something new for today and hope to see you again next time. Bye-bye!